For Tuesday's lesson, you can see that our objective on our study guide is to factor and expand or distribute linear expressions with rational coefficients. So we learned that rational coefficient, a coefficient is just a number that's in front of a variable. Rational means that it could be a fraction or a decimal. So let's take a look at what factoring and expanding actually mean. So this word expanding, as you can see, means to distribute. When we talk about distributing, we're talking about multiplying. We're taking what's outside the parentheses and applying it towards everything inside of the parentheses. And when I say apply, I'm talking about multiplying. So this first example is actually an example of expanding or distributing, which means I'm going to take this number outside of the parentheses and apply it towards or multiply it towards what's inside the parentheses. So I'm going to take my 5 and I need to multiply it by both terms, not just one, not just the other, both terms. 5 times 9 is 45. Let's use purple. 45. I use the same sign. And then 5 times 2r, well, 5 times 2 is 10. So 5 times 2r is 10r. So this expression would be expanded or distributed as 45 plus 10r. Now, can I simplify this at all? Can I combine 45 plus 10r? Hopefully you're saying to me no, because 10r has a variable, 45 does not. So these are not like terms. Its actual simplified version is 45 plus 10r. That is my answer. So don't get confused if you're asked to expand. Like, what? Ms. Boole never taught us to expand. No, you are just distributing. We've done the distributive property. That's all we're doing here. So this would be our final answer. Now to factor, let's switch it up. This word factor is talking about an expression that may look like this. So here we have two terms. It could be 3, could be 4. But basically we're trying to find out, is there another way that we could write this expression where we can pull out a common factor? Okay, remember, a factor is a number that goes into both of these numbers. So when I'm looking at 15x and I'm looking at 10, I'm thinking to myself, okay, what number goes into both of these two terms? Well, let's think about 15's factors. Well, 1 times 15 is 15, 3 times 5 is 15, 5 times 3, so on. Do they have any common factors as the number 10? Hopefully you're saying yes, they do. They both have a 5 in common. So if I were to pull out a group of 5, and by pull out, I mean to divide. So if I divide 15x by 5, what do I get? If that's confusing to you because we have a variable and a number here, think about this number 15. So if I have 15 and I divide it by 5, I get 3. Well, 15x isn't all that different. 15x divided by 5 would be 3x. The x comes with it. I keep my symbol the same, so this subtraction sign follows into the parentheses, and then same thing. If I were to take this number 10 and pull a group of 5 out of it, 10 divided by 5 is 2. So 15x minus 10 would factor as 5 times 3x minus 2. Now, something that I forgot to mention in the first example is that we can always check our work here. Okay, you don't have to just guess if it's right or not. If I were to now expand this expression, right, expand what we just did, let's see if it comes back to our original expression. So if I were to expand or distribute, 5 times 3x is 15x. I keep my minus sign. 5 times 2 is 10. So I have 15x minus 10. Is that the same as the original expression? Yes, it is. So I did this correctly. So 15x minus 10 factors as 5 times 3x minus 2. Okay, so that would be my final answer. The questions you're going to be asked to factor and expand are going to be very similar to this. You're just pulling out common denominators and or multiplying. And remember, expressions don't have answers. There's no there's no equal sign. So really you're just simplifying and writing in a different form.